Okay, good afternoon, everyone. Thank you for joining us for another Climate Live K12 session for students, educators, and the public. This is a series that has been run by the Columbia Climate School. My name is Laurel Zima-Sheehy, and I'll be facilitating the session today. For those of you who are joining us that are unfamiliar with the Climate School or who are joining us for the first time, the Columbia Climate School is a newly established school at Columbia University for transdisciplinary climate research. The school marshals the university's strengths in basic and applied disciplines and expands its resources to understand climate and its impact on society. The mission of the Climate School is to develop and inspire knowledge-based solutions and educate future leaders for just and prosperous societies on a healthy planet. So this is the first new school at Columbia in over 25 years, so we're extremely excited. And this school incorporates more than 20 different centers and over 700 people who collaborate among many different departments at the university to better connect, amplify, and advance new areas of climate inquiry, research, and impact across Columbia and beyond. So what we're hoping to do with these Climate Live K12 sessions is to introduce you all to the interdisciplinary work through our scientific experts. These are monthly sessions that run throughout the entire 2022-2023 academic year. So our last session this year is in June. And if you'd like any more information about the sessions, you can visit our website that I'll put in the chat in just a moment, or contact us via email. Each week we focus on a different topic, and each different session is directed toward a certain age range. So for today's session, it's titled Paying Attention to Critical Climate Messages from the Polar Regions. The polar regions are the site of profound climate change and regularly message us with observable change. Yet it's easy to dismiss the signals if we're not paying attention. So in this session, we are going to explore some of the range of signals that we are measuring in both the Arctic and the Antarctic, what they mean for the polar regions, and how they connect us, how they connect to those of us who are beyond the poles. So we are joined by Margie Turrin from Lamont Doherty Earth Observatory. And I just want to remind everyone that we are open to questions, so you can use the Q&A button at the bottom of the Zoom webinar function. You can ask questions throughout the presentation, and we will set aside time to answer them at the end. All right, Margie, I will hand it over to you.
Great. Thank you so much, Laurel. I'm going to share my screen, and we're going to just jump right in because I have a lot to share. So first of all, again, my name is Margie Turrin, and I'm really excited to be here today to talk to you about the messages that we have been seeing and reading from the polar regions. The polar regions are something that I spend a lot of time working around, and I just really always look forward to a chance to share some of this with other people. So today we're going to do a variety of different things. We're going to do a quick introduction to the polar regions. We're then going to highlight, I've just picked 8 critical climate messages from the polar regions. There are many, many more, but I don't want to take the rest of this to talk about some of those, because I really want to get us into what's changing, what's available to us, and how we can help. So we're just going to move right into this. So first, a little bit of an introduction in terms of the Arctic and Antarctic. They are polar opposites, and that's where their names come from. Antarctic mean opposite of Arctic, and they're really dominated by 2 different kinds of ice. So if you were to look at both of the poles, you would see that they are both white reflective surfaces. And that is one thing that they do have in common. That is where a lot of ice is sitting on our Earth system, and it's because of the way they're situated according to the sun, but they are completely different. So the Arctic is an ocean surrounded by land, and that white reflective surface that you see is actually frozen ocean surface. So that's sea ice. Whereas Antarctica, also white and reflective, is primarily land-based ice in the middle, and there is a fringe of sea ice around the edges. So Arctic land surrounding an ocean, Antarctic ocean surrounding our land. So again, they're very different. Oops, having trouble getting my slide to go forward. There we go. Okay, Then I want to just take a little bit of a different look at this. So we pulled off the floating sea ice or the sea ice in both areas. And now we're looking at just these land ice, these big ice reservoirs that sit in both polar regions. These are elevation maps. And so you can see by looking at them how much ice is mounded on top of these two land surfaces. These are the two remaining ice sheets on Earth, one in Greenland in the Arctic and one on top of Antarctica in the south of the Antarctic region. And if you look at them in comparison to the land topography around, you'll see that Greenland really rivals the elevation of the Himalayan mountains, and Antarctica rivals the elevation of the Andes Mountains. So they really are like mountains of ice. And if we were to put on top an elevation measure, you'd see that Antarctica in the very center is about 5,000 meters of ice thick. So that is an extremely thick amount of ice, again, like a mountain. And Greenland is probably closer to 3,000 meters of ice. Okay, so we've talked about differences, we've talked about similarities a little bit, and now we're going to go into these messages. So the first message I want to talk about is the loss of Arctic sea ice. So remember, the Arctic is an ocean, and we talked about the fact that that ocean surface is frozen. It's covered in ice, sea ice, and it has been changing in both thickness, so the thickness of the ice and the extent of the ice. So in the Arctic, we have a couple of different types of sea ice. We have this thicker multi-year ice, and then we have thinner seasonal ice. And it's important that we have both kinds. That multi-year ice is ice that remains with us all through the summer, whereas the seasonal ice is something that is there in the winter, forms in the colder months, and melts away. So if we were just to look at ice thickness, which is what this image is, you'll see that there are areas. So here's our scaled bar down below, and these are in meters of thickness. You'll see that we have up to 5 meters of thickness in some areas around the edges of the Arctic, but the center of the Arctic is considerably thinner. This particular image is from February 2023, so it's current. If we were to travel back in time to the 1980s, you would see a very different picture. So in fact, the thickness of the sea ice has halved. So if we were to go back to 1980, the mean thickness was about 3.5 meters or about 12 feet. That would be the mean, the average. So that means some of it was thicker than that, 4 to 5 meters thick. Nowadays, it's 1.89 meters, so less than 2 meters or about 6 feet. So we've lost half of that in that period of time, which is concerning because thinner ice will melt more readily, whereas that thicker ice is much more persistent. So that's thickness. Let's go to extent. And if we go to extent, we'll see that there's this like seasonal signal. So you see it growing and shrinking, growing and shrinking. But from 1979 down to 2022, you can see there's a pretty steady decline. There's one really low year, that was 2012. There was a kind of an anomalous situation with winds in the Arctic that kind of forced a lot of sea ice out the Fram Strait. And again, as the climate has been changing, it's a little bit harder to it's actually a lot harder to form that sea ice. So we haven't seen it recover and don't expect to see it recover. By the way, I do want to mention that when we're talking about sea ice and we talk about sea ice minimums and we talk about open Arctic in times of the year, we're really talking about summer. We're still seeing a nice cover in the winter, but it's that seasonal summer minimum that's important to us. And I want you to remember that white reflective cover is so important because it takes that sun heat energy and sends it right back out into space, whereas this darker surface really absorbs that heat energy. And what that ends up doing is creating a series of feedbacks. So the more you warm that ocean, the more you melt more ice, and it just continues in kind of a steady turn. So if we think about it, you go from this kind of a situation with that nice white reflectivity to this kind of a situation where you're just sucking in all that heat energy, and that energy then moves, it doesn't stay in the Arctic, it moves throughout the entire Arctic region and beyond into the mid-latitudes, etc. Okay, one other important thing about sea ice before we move on to our second message is that sea ice is a really, really important piece of the entire ocean circulation. So as sea ice forms, it's dropping out the salt that's in the ocean water so that it can freeze that surface water. And as that happens, it creates a density difference that really drives this ocean circulation, which we are all dependent on. So this is transferring heat and cool all around the globe. And as we lose sea ice, we're also slowing that circulation pump. Again, very, very critical for us. Okay, so we're going to move to our second message. Our second message is that our warming ocean temperatures is much more dramatic in the polar regions. So our polar oceans are really warming at accelerated rates. We call this polar amplification. It means things are happening in more extreme measures in the polar regions, and it's because of all the feedbacks that are happening there. So if you were to look at this, you can see that from 1982 to 2019, we're seeing trends of up to 1 degree C per decade of warming in the ocean. That is considerable. So when you think about the oceans, they are much less responsive than air. So the air is much more dynamic. It will warm and cool and warm and cool. The ocean takes longer to warm, and it definitely takes longer to cool. So if we're seeing these warming temperatures in the Arctic, it is definitely concerning. So the Arctic is one area, but let's pop down to the Antarctic and see what's happening there. And in fact, we see that it is not as dramatic as the Arctic, but we are definitely seeing a trend. So in Antarctica, it's a lot harder for us to get measurements. It's a lot more remote. The sea ice is kind of out around the edges of the continent. Buoys don't tend to work very well, so we don't have as many measurements, but we are seeing that, especially around East Antarctica, a 1/10 of a degree to a 44th of a degree C per decade. So 0.1 to 0.4 degrees C per decade. That's, again, it doesn't sound like a lot, but it can have dramatic effects when it's sitting next to the ice and is causing that ice to melt. I also want to point out that right around the edge of the ice sheets, you tend to get a lot of melt, and so you get this cool water on the surface. But underneath that surface layer, that's where we get that warm water. And in areas like here on West Antarctica, if you follow my cursor, you can see that we are seeing warming right up against the continent. And that's concerning because that ice, the continental shelf, which is a shallow area around the edge of the continent, is just allowing that warm water to get up and then rush up into and around the edge of the ice sheet itself, which causes considerable melt. So that is our second message. Oh, and sorry, I forgot that I had put in this wonderful picture. So this is a picture looking down on an ice shelf. This is the East Coast ice shelf, and I put a little picture to show you where it is. It's right at the base of the Antarctic Peninsula. And you can see that ice shelves, which are where the land ice has kind of flowed right off the edge of the land and is sitting on the surface of the ocean. It differs from sea ice because it's a lot thicker. So this can be 90% of this is going to be underwater, 10% on top of the water. This surface right here of ice that you can see above water can be up to 100 meters. And so then we have 900 plus meters below the surface of the water. And as that warmer water connects against the ice, you can see how it can start to melt away at the edges. I also want to add one other comment, and that is when I say warm water, and I'm talking about in the Arctic and Antarctic, I'm not talking about water at the temperature of the Caribbean. I'm talking about, just as I said, a little bit of a degree above freezing. That can have tremendous effects. So again, we need to be careful when we talk about warm water in the polar regions. It's not exactly what we would think of as warm water. Okay, our third message is in atmospheric temperatures, so warming surface temperatures. And this is a picture that shows you, it's kind of alarming in general, but basically you can see where things are really centered up in the Arctic and then down here around the Antarctic Peninsula. So if we look at global average temperatures, they've gone up about 1 degree C or 1.5, so almost 2 degrees Fahrenheit, compared to the 1950 to 1980 average. But that is nothing compared to what's going on in the Arctic and the Antarctic. So if we go to Antarctica, in that same period of time from 1950, it's gone up 3 degrees C. If you move to the Arctic, we can shorten that time frame. So instead of going back to 1950, we can compare from 1970, 1971, and see that it's gone up over a 3 degrees. So you really see that polar amplification again, where you're just seeing this tremendous warming. And just to kind of put it in context, that's 4 times faster in the Arctic than the global average. It's considerable. And in Antarctica, on the peninsula area, and I want to separate because the whole of Antarctica is not responding the same way, but in the peninsula area and in West Antarctica, it's 5 times the global mean. So we're seeing these much more dramatic changes in these 2 regions. Okay, let's move on to measure number 4, or what our message number 4 is. And this is going to focus on those ice shelves. Remember, I mentioned to you that image that I showed you of ice that's flowed off of the land. These are endemic to Antarctica. We have up to 43 ice shelves of considerable size around the edges of Antarctica, where the land ice just flows off. It stays attached to the land itself, so it's held in place, and it serves as kind of a guard to hold that ice back on the land. So it's really important in terms of slowing the rate of flow of ice as it moves across the land. You can see the size of some of these in this image. I want to circle this little area right here and point it out. This is the Thwaites Glacier. Thwaites is an area that's undergoing considerable change right now. And actually the image that was on the advertisement for this particular session was one that I took of Thwaites Glacier. I'm going to show it to you again in a minute. It's the front of Thwaites Glacier, so it is actually the ice shelf that sits on the front. This area has been changing much faster than most other areas in Antarctica. It's an area of concerted study right now because the ice tips way back into the interior. And so that is something that is concerning, because if you lose those shelves as they start to break away, that ice behind will start to flow much faster. So we're going to, this is that image of Thwaites Glacier that I mentioned to you. This is the ice shelf. And again, I just want you to understand, we're talking about a lot of ice. We didn't see a picture of it on that last image because it's smaller than what they've included in here, but you can see it is considerable. And so now I want to take you to a glacier that's, let me just show you where this is. This is the Larsen Glacier. So it's up here on the inside of the peninsula. This is a glacier. There are 4 Larsen glaciers. There was A, B, C, and D. Right now, there's only C and D left. And I'll show you what happened to B over the period of 6 weeks back in 2002. We're just going to tip through time and we're going to watch it disintegrate. And this is what happens when you have a warming atmosphere and you have a warming ocean that are both working on this floating, although it's still very thick, bit of ice. It can erode this away from top and bottom. And then after that, we have measurements showing this ice just accelerating off. So that was our measure number 4. Okay, the next 4 messages are going to actually focus on the land ice. So this, I wanted to share with you this picture of Antarctica, just to give you a sense of scale. as to how large that ice sheet is. This is ice all back around, going back into the picture. This is the front area where you see some exposed rock. And I'm going to call your attention to this little teeny boat that's down here. This is a Zodiac that is bringing a group of our science team into the land. But that kind of gives you the sense of scale of the amount of ice that's actually down there covering this land mass. And 98% of Antarctica is covered by ice. It holds 90% of the world's ice. And I'll give you another kind of look at that ice just so you get a sense of how it's just dripping, falling off the edges of the land. So a considerable amount of ice that's there. And that ice is becoming more and more vulnerable. Then to kind of show you the Greenland ice sheet, again, different end of the world, but it also has a considerable amount of ice that's stacked up on the land. It's 3 kilometers thick in the center, and about 80 to 82% of Greenland is covered by an ice sheet. And the center is very, very thick. It's actually pushed the land down beneath it. So here's our 3,000 meters, so you can get a sense. Okay, so now we're going to look at those next 4 messages. Message number 5 is that surface melt on the ice sheet is actually increasing. So more days of surface melt are occurring each season. This is a compilation where we're looking at from 1979 to 2007 on the left, and you'll see that there are more and more days, as well as that those melt days are moving further into the interior of the ice sheet. On the right, we're looking at a 2022 compilation that's showing you, as I just mentioned, we have these areas where there's consistent melt, over 100 days of melt in some of these areas, and you can see it moving into the interior of the ice sheet. And as I mentioned a second ago, this is 3,000 meters thick in here. The edges are not so thick, so these are closer to 500 meters or so and thinner. So as you're moving in, it means that you're getting into this thicker ice, which is a bit of a surprise. We think of ice sheets as the higher the elevation, the more protected they are from a warming atmosphere. And so this is concerning when we see this climb into the interior. And so here's another way of looking at the same challenge. These are surface lakes and channels that form on the Greenland ice sheet. We have seen these for years around the edges at the lower elevations, and this is not concerning when you have snow that's falling and accumulating into ice in the higher elevations. You expect to see some of this melting along the edges. But now, as I mentioned, we're seeing this moving further into the interior. So back here in 1971, we're at a much lower elevation. We moved to a little bit higher elevation, about 1,700 meters above sea level by the mid 1980s. Now we've seen much steeper rise on the ice sheet. We're up about over 1,800 meters above sea level now. And this is then modeled into the future, and it looks as if we're going to keep moving up and in. And you can see that over a period of 71 to 2012, this moved in by 53 kilometers or 33 miles. That's concerning. And we have a little model that we'll run, and we'll just show you how this works. So again, thinking of this as the thickness of the ice sheet, and you can see how these lakes and melt areas are moving further up the ice sheet. Again, concerning. And as these form, these little lakes form, they can force their way into a fracture and end up taking water all the way down to the base of the ice sheet, which can then help to move that ice sheet and cause melt from below. So again, another kind of important message that is also a bit concerning. In Antarctica, we're seeing a similar thing. So we're seeing more days of melt tend to be around the edges. If we were to overlay that ice shelf map on top of this, you'd see that a lot of these might overlay with those ice shelves. So again, more melt around the edges. Message number 6, we're seeing that ice is flowing faster off the land. And I apologize, these two color bars are different, so we'll look at them independently. You can see in Antarctica, the fastest flowing areas are going to be on these ice shelf areas. This is Thwaites. Remember, we talked about Thwaites and saw a picture of it. This is its neighbor, Pine Island Glacier, and these are very fast flowing areas of ice. Over in Greenland, the yellow is the more stable. And when we get to this hot pink, this is where we see this ice really moving. The fastest moving glacier on Earth is the Ilulissat Glacier, which flows right here into Disco Bay. In the summer months, it can flow up to 113 feet a day. So moving that ice very, very quickly, which is over 3 times faster than the fastest moving glaciers in Antarctica. So definitely something to pay attention to. And as that ice flows faster, surprisingly, it also then would retreat. So if you think about this, the ice is flowing faster, which means it starts to thin out. It's melting and thinning. And as it's thinning, it then starts to break away. And then you see that whole glacier kind of retreating back. So this is, again, Ilulissat Glacier, that fastest flowing glacier that I mentioned in Greenland in 1850. And you can just see this massive retreat through time, takes us back to 2007 and even beyond. So way into the interior. Now we're a little bit, I wouldn't say way into the interior. We're kind of tipped back just about this far now. But it's a glacier that's being studied quite a bit because of its fast changing ways. Message number 7 is that we're also seeing a loss of ice elevation. So this is Pine Island Glacier. This is Thwaites over here. This is Pine Island Glacier over here. This is the fastest moving glacier in Antarctica. And if you just took this line across the glacier as it flowed, we had a satellite that was able to collect consistent data over this 4-year period and just looked at the same spot over 4 years. So this was our baseline, which was November of 2003. November, if you think about it, is the beginning of that Antarctic summer. So their summer is the opposite of ours. So this is when we still have this nice cool air temperature and ice compilation. By April 2007, 4 years later, we've seen this big elevation drop. And when that first came in, people thought, oh, you know, that's a lot. Maybe some of it's seasonal. But then when you go back and look at October of that same year, you'll see that it's gone down. We've lost almost 20 meters of ice. And then you look at that in comparison to snowfall in this area, which is about 0.5 to 1 meter annually, depending on what's going on with the weather. It is considerable. So that is a big loss. So again, loss of ice elevation. And this is a picture of Pine Island Glacier. This is the ice shelf on the front, just to put a face on the name of some of these things. It's a lot of ice. Again, just a really incredible amount of ice down there. And our last measure that we're going to talk about, or message that we're going to talk about, is that the ice sheets are actually losing mass. And this is an image that was collected from satellites that looks at ice mass loss through time. We're going from 2002 to 2021. You can see in Greenland, boy, we're losing it just about everywhere. Like there is just a tremendous amount of loss in almost every corner of Greenland. In Antarctica, it's not the same message. Again, we talked about how the peninsula is a little bit more exposed, as well as West Antarctic ice sheet. And this area right here, if you recall, is Thwaites, the area we're focusing on right now. This is Pine Island Glacier, the area we just looked at. So this is a very sensitive area of Antarctica. Okay, so I'm just gonna, these are our 8 critical messages. And so how does this affect us? What do we hear from these? Well, first of all, let's go back to sea ice loss. So sea ice is already floating in the water. It is not going to contribute significantly to sea level rise when it melts, not directly. But what it does do, as I mentioned, is it causes that incredible feedback, that polar feedback and amplification that just keeps accelerate the warming, and that spreads all over the globe. So it is a critical piece of our polar regions that's important. The warming ocean temperatures is accelerating melting of the sea ice and land ice, along with those warming surface air temperatures. Again, that's causing ice melt. It's really important when you combine that ocean temperature and the air temperature for those ice shelves that are in Antarctica. It kind of hits them from top and bottom and really is working on kind of eroding them. In addition, this warming air temperature is kind of reducing that, we call it a barrier between the cold air in the Arctic and the kind of mid-latitude temperatures. And that's what's driving a lot of this kind of chaotic weather that we have experienced over the last decade, is kind of what we consider wonky summer and winter months. The collapse of ice shelves was our fourth message. And with that, we're seeing this land ice behind can flow more readily into the ocean, causing sea level rise. And then all of our land ice indicators, so more days of surface ice melt, flowing faster, ice flows faster and it's retreating, loss of ice elevation on the glaciers, less ice mass. All of that means that we have moved ice into the oceans, and all of that is contributing to sea level rise. There's a lot of sea level rise tied up in our ice sheets, about 64 meters all over the world, or 210 feet all over the world. We are not expecting anywhere near that amount to end up in the oceans. I want to make sure everybody knows that in our lifetimes, or in our children's lifetimes, or into the future. It takes a long time to change that ice, but it doesn't take a lot to have an impact on some of our communities, our coastal communities. So, and for the rest of us. So again, all of us are affected by sea level rise, even if we're not a coastal community. Okay, so now we've talked about some of the messages and the impacts. I really want to then spend the rest of this time talking about opportunities and positive messages, because there are some. So this is a picture that was taken in Korshorsvåg in Greenland, which is fairly far up on the northwest of Greenland. This was in September when we were there working with community groups. And I included this image because it ties to a message that we were sharing with them. So we were sharing a message with them about our predictions as to what was going to go on with sea level in Greenland. I'm going to take a minute and say this is a little bit tricky, because everywhere that we think about sea level, we think about sea level rising from this additional ice that's moving into the oceans. Around our ice sheets, Greenland and Antarctica, it's actually going to be the opposite, because the land has been way down by ice for so long. As it loses the ice, the land's going to kind of rebound up, move back up a bit. And that ice has been attracting the ocean towards it because it has like a gravitational attraction, like a mountain. And as there is less ice, that ocean kind of relaxes away. So for them, it results in sea level fall. But the message that I want you all to take away is that when we did our predictions and we did our modeling, what you see is that depending on what our emissions are, the impacts can double. So this is looking at where we are today, right? 2020. And if we continue with business as usual, we will end up by 2050, there's not a whole lot of difference. By 2100, the impact on Greenland, which would be a reverse impact on the rest of us, is going to be double, right? So very, very significantly different depending on what our emissions are. I also want to clarify that doesn't mean that we don't have to do anything until 2020 and we can start changing our behavior then, because this is heat that's going into the system. And so it's at 2050 that we start to see this big spread in terms of impacts. but it doesn't mean that we have until 2050 to suddenly start changing our behavior. So again, we have control. There's a lot that's in control. There are some things baked into the system, but we have a lot of opportunity. So now I want to talk about some of the positive steps and actions that have been going on, because I think they're really exciting and empowering. So first of all, there's a big push in the Arctic to bring the Indigenous community voice into our discussions, into our research, and really do a better job of learning from them in terms of the knowledge that they've gathered over the many hundreds of years that they've been working up there, and living up there. We have satellites and measurements that go back into, the 1990s, 1970s in some instance, but they have lived experience that goes back considerably before that. And so we want to bring their voices in. This is an image of a shared Arctic variables, which was established by the Arctic Council in 2020. This is a council of communities that all live and work in the Arctic. We are in it in the US because of Alaska. And so we're part of this Arctic Council. And the decision was made that we wanted to change the way we were doing a lot of the research. So Indigenous-led benefits identification means the Indigenous would pick what was important to them to study. And then we would regionally work on this science decision-making, is come up with what we were going to focus on, and then share those science research opportunities at a global network. So we'd all work on it based on what some of the priorities are that the Indigenous set. That doesn't mean that other countries are not setting priorities, but Indigenous voices are really given a strong priority. A couple of other really cool things that have happened. So in 2019, this marine protected area was established. It's between Greenland, it is in this area between Greenland, but the real priority areas by Baffin Island and Devon Island. This is an area where there are a lot of narwhal, polar bears, a lot of species that really need protection and need that cold water, need sea ice, and are critical to the Indigenous populations, the Inuit in this area. And so through collaborations with the Canadian government, the Inuit Association, and the government of Nunavut, there was an agreement that put this area aside as an Inuit impact and benefit agreement. So that is a really important move that I'm excited to see occur. A second collaboration that's led to these really positive steps is setting up a new marine protected area in the Canadian High Arctic. So this red area that's hatched here identifies what we've called the last Arctic sea ice area. This is where in the summer, it's expected that we would have the last persistent sea ice. Even if we lose the rest of this, we expect that we would still have sea ice in this area because of circulation and wind patterns. And so this is a really important habitat area, and working with the communities in Nunavut and the Inuit associations, they have set aside this purple hatched area for 5 years as a tentative marine protected area. So what they've done is, they haven't got it fully established yet, but they're in the process of trying to work out the agreement so that it will be fully established by the end of that 5-year period. Again, a very exciting and important space. So just to kind of point you to where the last one was, it was a little bit further down here. This one is here, and the next one I'm going to talk about is also in this area. So this is a really critical area, this area that holds the last sea ice. And this area is kind of interesting. It's called the Pikerlesorswuk protected area. It isn't protected yet. They're working towards establishing it. This is a Polina. So for those of you who have never heard of the word Polina, which is kind of an interesting concept, it's a persistent open water area. And so the areas around it might be covered in sea ice, but because of circulation in the ocean and the winds, this remains open, ice-free, a very, very important space. It's a really important in terms of fisheries, in terms of the communities in terms of their usage of this for seal, etc. And so making sure that it stays protected is really important. So again, those are three kind of areas that are at different stages of being protected for the indigenous communities. In Antarctica, things are a little different. In Antarctica, there is no indigenous population, but in 1959, we were able to set aside Antarctica for science and peace, which is pretty incredible. There were 12 original signing countries. There are now 55. So that whole continent, which is 1.5 times the size of the continental US, is set aside for peace and science, an amazing thing. And one of the pieces I want to call out is they have these very special protected areas, because even when you're doing research, you can impact some of the rookeries and fragile areas. So they have these special protected areas, and they also recently established this Ross marine protected area. And I do want to mention, so I've mentioned these marine protected areas, they're not going to solve a climate crisis. They're not going to change the climate change piece, but what they do is allow species that are being stressed a place where there's not an additional stressor on them. So it allows these ecosystems to kind of rebuild as ecosystems and build some resilience in. And that in itself is a really important kind of way of thinking. So we might not be able to avert the climate impact in this area, but we can allow the species that are there a chance to kind of regroup and protect and build themselves up. Okay, so what can we do? I am a really big proponent of the power of a circular economy and trying to move away from what I see as our disposable economy, where we use it once and throw it away. We get tired of something, we just toss it in the garbage and get rid of it. Let's think about how we can reuse, how we can share, how we can repurpose. There are a lot of businesses that are starting to do this. There are vendors that are starting to do this. So in our own life, we can do it, but we can also support businesses and vendors that do this. So I would really encourage us all to think about looking for those kinds of opportunities. Along with that, buying locally whenever possible is a super powerful way of doing things. I think we probably all would agree with that. Walking the walk. So that means, let other people see what you're doing. Don't be shy. You don't have to be in people's face, but don't be shy about, what you're doing and why you're doing it. I think that's really important. And the people can see the way you're behaving. It encourages them to do likewise. Again, talking the talk with other people. Let's talk about climate. That's one of the things that we tend not to talk about as much as we should. And then lastly, just getting involved in groups that are doing the work. And I shouldn't say lastly, because there are many, many other things you can do. But again, just thinking about who can I pull together with, who can we move together to actually create change and do some positive. I want to close by telling you about 2 different opportunities and encourage your participation. So one is focused on students. We are building a polar climate science group of students that are going to learn about polar science. They're going to discuss it with scientists. They're going to help develop some resources that can reach other students and the public. We want them to kind of commit to opportunities to educate the public, to work with us on finding those opportunities and making presentations. So if you were at all interested in that, we have several projects that are focused on that, and we really want to see that jump off the ground. So please feel free to email me. My email's here, or you can reach out to Laurel and find a way to me. And then for teachers, we also have a summer research experience for teachers, which would be focused on developing resources for climate education, taking resources that already exist that we have and matching them to standards, working with us, learning from scientists, all those really fun, positive things. So I really hope that we have some people that are interested in those opportunities. And with that, I'll say thank you and see if we have any questions.
Thank you so much, Margie, for this amazing presentation and also just sharing about what we can do and these different opportunities to get involved. So for those of you who are joining us live, feel free to use the Q&A button at the bottom of the Zoom webinar to ask your questions to Margie about anything, the content, these opportunities. If you're a student and want to learn more about the opportunity to join the Polar Climate Science Group, or if you're an educator and want to learn about the research experience that you can participate in. Okay, we have a question from Dennis. Dennis asks, if sea ice decreases, will there be shipping in the Arctic or Northwest Passage?
Absolutely. There has been a real push to have that occur. There certainly is already increased shipping traffic up there. There have been a lot of conferences and studies on what that will mean in terms of disruption of the habitats, as well as, if you think about it, as a ship goes through, there's a lot of pollution that comes out of those ship stacks as they're moving through. That black tends to sit on top of the sea ice, and we learned already that as you darken the color of sea ice or lose sea ice, that you're now not reflecting, you're absorbing. So it is going to add to that feedback. There's a benefit, of course, and nothing's ever always bad. So there's a benefit to different countries and communities who will find a shorter time in terms of moving goods, but it definitely has an impact and concern.
Yeah, something that we hear in regards to climate impact is that there are winners and there are losers, but ultimately for our global community, climate change is causing a lot of challenges and definitely more challenges than benefits.
100% agree with you.
Any other questions? Margie, if we have any students that are joining us asynchronously and they want to get involved in this Polar Climate Science group, how could they go about doing that?
Yeah, so hopefully if they're going about it asynchronously, they would see my email. So the best way to do that is to email me. And it's mkt@ldeo.columbia.edu, and it's on the last couple of slides. We're really excited about it. Our target group is high school age, but depending on if they're middle schoolers that are interested, we might be able to think about that. But really excited about bringing those together. And we are really, originally we were thinking about all in person, but I think we've realized that since our projects are very disparate, that we have a virtual opportunity. So the ability to work with people in different locations is absolutely part of what we're thinking.
Amazing. And is there any application process or any prerequisites that students would need to have to participate?
Yeah, so if you reach out to me, I can shoot you back some information about what we're looking for. But our interest is really that you have a commitment to participating over a period of a couple of months at minimum, that you are comfortable with being involved with a group of students so that we can have conversations and move things forward. And our goal is that you would reach out into your own student population and through your own schools and help us to share the information. I think that polar climate is something that is not something that a lot of people are familiar with, and it is so important to the rest of us. It isn't isolated, it is absolutely linked to us. And so really trying to bring that into the conversation is our goal.
Couldn't agree more.
And
yeah.
also to have fun, make it fun. I mean, we want to share ideas and do it we don't want to be depressed. So I'm hoping that in the things that I shared with you today, you recognize that there are positive things happening, and we are creating benefits.
Absolutely. There's a lot of power with youth climate action right now. The movement is just gaining momentum. And so this is a great way to be a part of it.
100% agree.
All right. Last call for any questions from anyone that is joining us live. I also just wanted to share in regards to the research experience for educators, where you have the opportunity to work with Margie to develop some polar curriculum. The application process does close February 17th, so we're coming right up onto that deadline. So if this is something that you want to participate in, I encourage you all to apply sooner than later, and I will put that link in the chat as well, just for those of us that are joining live.
Great. Thank you, Laurel. Yeah, we're excited about that.
All right. Well, I don't see any more questions. Margie, thank you so much for joining us for the past hour or so. It's been really wonderful hearing about all the new things that you've been working on.
Thank you so much. Thanks for inviting me. It was fun.
All right. Bye, everyone. Thank you.